AMD, formerly Xilinx, a leader in the FPGA industry, provides Vitis AI as an AI solution for its FPGA chips. But it is known that it only supports high-end chips such as the ultra-scale Zinc EMP SoC or higher, and support for the Zinc chips has been discontinued as it does not provide satisfactory speeds. Therefore, there is no AI solution available for the popular Zinc 7000 chips that are consumed in the largest quantities. In this video, we will provide a free AI solution that can run at a high speed on the Zinc 7000 FPGA boards and explain how to test and apply it to the field of applications. This AI solution uses a part of the AI hardware design based on the Zinc 7000 chips developed by Neurocoms and commercially applied to AI set-top devices. Transform your FPGA board into a high-speed AI machine. The boards currently supported by this AI solution are the RDZ720, Pink Z1, and Pink Z2 boards. We plan to expand to more board types in the future. These boards are either products of Digilent or related products, and use AMD's Zinc Z7020 FPGA chip. They are widely used as training equipment in schools and can be easily purchased from various sellers. In particular, these boards support both HDMI video input and output interfaces. If you have one of these boards, you can test it out right away by following this video. In addition to its basic use as a learning tool for digital circuit design with FPGA, the Zinc board can also be used as a vision AI hardware platform. Now, how to install and utilize the Zinc boards will be explained. First, download the AI on zinc.zip file through the link posted in the comments section of this video. After downloading the file, unzip it and save the files to a micro SD card. Note that the boards listed above are pin-compatible to each other and can use the same binary files. Insert the prepared SD card into the SD card slot on the board and find the boot option jumper on the board and set it to SD card boot. For the RDZ720 and Pink Z1 boards, this jumper pin is located at the top left, so just connect the top two pins with a jumper. For the Pink Z2 board, the jumper pin is located at the top right of the board. Connect the leftmost two pins. Next, use two HDMI cables, one to connect the HDMI output of your laptop and the HDMI input connector on the board, and the other the HDMI input of your monitor and the HDMI output connector on the board. Connect the board to your computer with a USB cable to power it. When you power on the board, a second screen of a laptop computer is displayed on the monitor, and the recognition results of the deep learning algorithm are overlaid on the screen. At the top of the recognition window, which is drawn with a green box, the name of the recognized object is displayed dynamically, and below it, the probability value is indicated with a yellow line. If this line extends all the way to the right, it means that the deep learning algorithm has recognized the object with 100% probability. At the bottom of the recognition window, the name of the currently running model, processing speed, and latency time are displayed. If you play YouTube or a video file in the recognition window on the laptop's second screen, the video will be recognized and the results will be displayed in real time. Of course, you can also use another HDMI video source instead of the laptop's HDMI output. In this solution, the deep learning classification algorithm is hard-coded into the circuit of the floating point multipliers using Verilog hardware design language. The recognition rate of this algorithm on the standard dataset outperforms that of the VGG16 deep learning model, demonstrating a decent accuracy. This solution contains 4 sample models trained with this classification algorithm. From now on, I will explain the 4 models one by one. When powered on, a model that recognizes 190 general objects runs. When running another model, pressing the first button from the far right of the 4 push buttons on the board will switch to this model. Objects recognized by this model include general objects such as cars, bicycles, chairs, dogs, cats, and person. When you press the second push button on the board, the ImageNet model will run. ImageNet is a standard dataset used to evaluate the accuracy of deep learning algorithms and recognizes special 1,000 objects. It includes over 200 breeds of dogs and a variety of other animals, including African and Asian elephants. Please test it using various images from the internet. Next, pressing the third push button will run a model that recognizes gender and age group from a person's face. By recognizing faces in a similar arrangement to ID photos, It recognizes age groups in 10-year increments from under 10 to over 70s for both men and women. How old does AI recognize your face? Check it out. The fourth push button runs a model that detects whether there are cracks in the concrete walls of a building. You can test it by pointing the camera at a concrete surface around you, or by downloading an image of the concrete surface. This model demonstrates that by training complex patterns using deep learning, it can be used for purposes such as recognizing whether a product is defective while it is being manufactured in a factory. Next, we will explain how to receive the recognition results as electrical signals. There is a file called gpio.txt in the SD card you prepared. If you write the ID number of the desired object in this file, the model will generate an electrical signal on the designated pin on the board whenever it recognizes that object. The ID number of each object can be found in the file called ClassLabelIDs.txt inside the SD card. If the specified object is recognized, the color LED lamp on the board lights up, and at the same time, the voltage level of the IO13 pin of the GPIO connector becomes level 1. If you connect an LED lamp to the IO13 pin and the ground pin next to it, you can see that the LED responds to the recognition result. By wiring these connector pins externally, the board could be used for practical purposes, such as opening a food bin when a cat appears, or automatically removing defective products in a factory. Let's set the connector pin to activate when a cat appears and test it by plugging in an LED to that pin. You can see that when a cat appears, the LED turns on immediately with almost no delay. The real-time recognition results are also output through the UART serial port. First, connect the board and the computer with a USB cable. Open Device Manager by pressing the Windows key plus the X key and check the number of the added serial port. In this case, it is COM19. Then, while running the Zinc board, open the serial port you checked earlier with your preferred terminal program. I will open it with a program called PuTTY. Set the speed to 115,200 bits per second. When the first slide switch on the board is off, the recognition results for each image frame are output through the serial port. When the slide switch is on, statistical data for processing each frame are displayed in detail on a frame-by-frame basis. Next, the usage notes for this solution are explained. This solution only accepts RGB video sources as it supports the DVI standard, which is a subset of HDMI. Therefore, if the video source does not support the RGB color space, there is a possibility that the HDMI video may not be recognized. The input resolutions of the supported videos are 1080p and 720p. Additionally, if you run AI at high speeds, the chip will overheat and it will be difficult to last more than a few minutes without a heatsink, so it is essential to attach a heatsink to the FPGA chip. The Zinc boards mentioned above can be purchased from electronic component shopping malls and general online shopping malls such as Amazon or Coupang. Neurocoms also sells a small amount of RDZ 720 and Pink Z1 boards through its sales site. Please refer to the link in the comments for the address of the sales site. If you purchase it through this site, the board will be sent with a heatsink attached to the FPGA chip. In addition, a micro SD card with the hardware source code files and an LED lamp for pinout testing of the recognition results will be sent together. This channel is primarily aimed at those interested in AI hardware design. In subsequent videos, we will explain how it works, details on the hardware source codes, and analysis of the chip's computational efficiency. In addition, for those who want to implement Vision AI as a service, we will cover how users can train new deep learning models and how to implement various applications by combining classification and object detection algorithms. In the follow-up videos, we plan to improve this solution to enable the execution of custom-trained models and expand the input video interface to USB cameras, CCTV IP cameras. If you have any further questions, please leave them in the comments. And if you would like to collaborate with Neurocoms on AI hardware design or designing custom deep learning models, please refer to contact information in the comments. Thanks for your attention. See you in the next video.